Hello, my name is Trevor Gross, and welcome to my infographic presentation for semester research project concerning microservices architecture. Microservices architecture is defined in Chapter 6 of the Somerville textbook, and it is a system of implementing logical software architecture. The server is constructed as a series of corresponding microservices, and this dynamic client-server connection permits additional features and a greater distribution of workload. An MSA takes the entire process from the server and sends pieces along to other servers that perform part of the function concurrently with those other parts. Then this is sent back to the original server and assembled onto the final product. This is a process that was first developed years ago around the turn of the century, but then it was shelved because it was more expensive and just not necessary for the time. As products have become more complex nowadays, MSAs are becoming the preferred option. But why? From doing some literature research, old monolithic architectures, which I'll refer to as MAs, used to be the industry standard, but more is required for computing, as I said, and these styles cannot keep up with the increasing amounts of data and functionalities being thrown their way. Furthermore, these old systems cannot handle the large bandwidths and decrease overall efficiency because of that. MAs function by linearly completing one process on one server and one pipeline, which severely limits the performance when you have processes that require multiple complex pieces, for example, machine learning. Many companies are switching their server infrastructure from MA to MSA because their old framework simply cannot withstand what they are requiring of it. As opposed to the single-bound approach of old, MSAs distribute services independently as to improve features across the board. MSAs can improve scalability, performance, availability, monitorability, security, and testability, all rolled into one package. This chart shows the most commonly mentioned reasons from other peer research as to why to switch to MSA, with scalability being far and away the most common because companies can easily increase their bandwidth or processing speed of each feature. Continuing into this, the ability for MSAs to split workloads allows for a parallel processing environment as opposed to MA's linear format. Since each segment is not affixed within a single monolith, there's opportunity for individualized expansion for each feature, which can greatly cut operational costs. This allows companies to pick and choose what they want to expand upon without having to affect the rest of their pipeline. And one article mentioned that this can cut costs by up to 90%, assuming you are performing a highly complex process on a monolithic architecture. To evaluate this, the additional connectivity of MSAs as opposed to MAs allows for more complex tasks to be solved in more efficient manners, as I just said. As always in computer science, however, there's never one solution, and MAs are preferred in some simple systems. However, as the number of features for each program increases, MSAs will eventually become the only option. This is shown in the graph here, and it shows that MAs are more productive in these less complex areas, but as the complexity increases, MSAs retain approximately the same productivity level with a slight hit occurring as it becomes more complex, which makes sense. But monoliths take a huge drop off, and the productivity difference is very noticeable and something that causes a lot of companies to switch to MSAs. This is due to the decreased coupling of microservices that reduces the attenuation of productivity. Some interesting information is that Amazon, Netflix, Uber, and Etsy all attribute their enormous IT success to the adoption of MSA, while all four high-volume companies are heavily reliant on expansion. The ability to scale features has increased their business agility and profitability. This development shows MSAs working in the real world. At Amazon, they kind of created this whole thing, and they pulled apart this source code into separate chunks that each work towards that specific goal, and then wrapped those into a web service interface, so each function had its own microservice. Now AWS, which is part of Amazon, can support similar structures because Amazon largely popularized this MSA architecture. In fact, the other three companies that I mentioned here, Netflix, Uber, and Etsy, use AWS for this feature because Amazon popularized it and kind of dominated the sphere. But overall, thank you for watching my video.